In this video, we're going to see how working with Python and programming with Python, it's just really fun to program and to work with. It kind of reminds me of this video with defining fun to drive with Ferrari. So that's as close as we're going to get to a Ferrari in this video, but let's get to it. So lambdas. Lambdas are an anonymous function, right? They are anonymous functions that allow us to really create some logic, some computation on the fly and without a name. That's what anonymous means. So for example, in this first line here, line number 1, this is the lambda function. I'm assigning it to lambda function. We normally don't do this. This is just to show in this example, this is for demonstration purposes only. But just to show you what a regular function is here, line 4 and 5, it's called just a function. It takes an integer, hopefully, and it squares it. So not using a lambda function, if you take 5 and you square it, you should get 25. And you can also take line 8 and execute it, and you're going to be running this lambda function. Again, lambdas are anonymous. This is usually how you write them. This is only for demonstration purposes, so you can see that we get the same result. So if we run this code, we'll see that 5 squared, they're both 25, and that's really what a lambda function is. However, we do take lambda functions and use them specifically in other features, right? Other features of the language. For example, filter, map, and reduce. So let's get into that and walk through what that means. So imagine that we have a list of integers like this, and we're going to assign them to my numbers. That's going to be the variable. Notice how in line number 3, we can apply a filter, right? We can apply a filter, and what is that filter? It's going to be some function, in this case, a lambda function. And we're going to apply that lambda function to that list of numbers that we're defining in my numbers. So whatever numbers in the list evaluate to true with this given function, we're going to go ahead and assign and have in this even numbers filter. Then we're going to print the even numbers filter and just cast it to a list. And by the way, how would you do this without a lambda? Right? You still have filter like this in line number 17. You still have filter and you pass in the function that you want to use. In this case, it's going to be this function in line number 10, get even numbers, and that basically returns true or false, whether or not it's even. If it's divided by 2 and it doesn't have a remainder, it's an even number. Otherwise, it's a false, which is not an even number. And what numbers or what list are we going to apply that to? Well, we're going to apply that to my numbers, and that's the same list above on top of this file. So you see how we can apply filter with a regular function, and we can just print the list of even numbers without using the lambda, which is what we're getting here in line number 17. So as you can see, what is the beauty of using lambda with filter and some of the other functions that we're going to talk about, like map and reduce? It gives you this concise way of writing the logic. It's more readable, can be more maintainable. You have to consider for yourself the cases that are more readable. In some cases, maybe it's not as readable. So you have to be the judge and take that into account. So that's the big idea of using lambdas with filter, and the same thing goes with map. Map, it's just a function that we could use, and we can pass a function to it, and in this case it's a lambda function. If this is true, actually this is not filter, this is basically going to apply this logic to every element in the list of my numbers, and it's going to return a new list, right? That's what map does. It returns a new list containing the new items after this logic is applied to every element in the list. So let's run this and see what happens. You could see that here we have 100 to 8, 64, and 10. This is this first one here is printing all the even numbers from this list up here, right? From this list up here. And the next one is, hey, return a map, right? This is going to be a map returning whether or not something's divisible by 2 without a remainder, if it's something's even or odd, in other words. If it's even, return true. If it's odd, return false. So, of course, you can tell that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we do have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of these are the same length, right? They're the same length, 10 and 10. And you can tell that the odd numbers are 1, 2, 3, 4, 5, 5, and 7, right? So 1, 2, 3, 4, 5, and 7, and the last one, which is 11. So that tells you that this does work, right? The map returns a new list, and it gives you new values for whatever you did, whatever computation you did within that lambda. So again, this is easier to write like this instead of, again, creating a function like we did here, and invoking it here, basically saying which function it is. Notice that we're not saying, we're giving the reference here. We're not invoking the function here, right? We're just saying, hey, this is the function that we want to run to filter. And this is the list of numbers, for example, that we want you to consider. So, hope you enjoyed it. But before I end this video, I just want to show you one last thing, which is, why are these lambdas used all over the place? Well, consider that you're sorting, and there is a video. I do have a video for sorted versus sort, so take a look at that. But just to show you, we have a lambda here that we're going to invoke in order to sort this, right? There's other parameters like reverse and things of that nature, but the big thing is, notice that we don't have a named function. We have a lambda function. We want to attach this function with this sorted functionality. So there you go.